Hi, good day. In this video, I would like to discuss our topic about corrosion. How can we avoid corrosion and what are the desirable things that we can do to minimize corrosion? But before that, I would like to introduce myself. I am Cadet John Ristel Bisuler and with my team, Cadet Sarah and Cadet Saniko. Have you ever wondered why the colors of some metals like iron, silver, and copper gradually change with time? In this video, you can learn about how, why, and what is it happening.
Corrosion is a natural process that converts a refined metal into a chemically stable form such as oxide, hydroxide, and sulfide. It is a gradual destruction of materials, usually in metal, by chemical and or electrochemical with the environment.
Have you ever seen a brand new car? It looks so fresh, shiny, smooth, and vibrant. But at the same time, if you've seen an old car, it looks dull, broken, and rough. But what makes an old car look so dull? If you look closely, that car gets discolored at different places, and these places are reddish brown layer, and this is what we call rust. And rust is the reason behind the smooth and shiny car turning into a rough pieces of metal. Imagine four objects: an aluminum toy, an iron nail, a copper pipe, and a gold ring are left out and open for many years. Which one will be the best condition after rediscovered? If you think that the gold ring is likely to be the best condition, the copper pipe and the iron now will appear in a worse condition, but the aluminum toy is also preserved very well. Most likely, the iron now will appear in the worst condition. This is because of corrosion. Corrosion is described as a formation of compounds on the surface of metal when it is exposed to air and water. An electrolyte like salt water typically once a metal corrodes. It forms compounds known as oxides or hydrated oxides. The nail was made of iron, rusted. This, by the way, is the only time you should use the term rusting. All other metals are considered as having been corroded when they react with water and oxygen it in the air. But why would the nail be more corroded than the aluminum toy, the copper pipe, or the gold ring? Because metals have different reactivities. Iron corrodes faster because it is more reactive than the copper and the gold. But you may be wondering, why didn't the aluminum toy corrodes the fastest? The truth is the aluminum is more reactive than the iron, so it reacts fastest with the oxygen from the air, forming aluminum oxide. Aluminum oxide is very unreactive because once the oxide layer is formed on the surface, it binds very tightly to the surface of the metal, so no cracks can form and cause further corrosion.
Much of the equipment that is used in the oil industry is bolted in place, often at high. Here it exposed to adheres weather condition if we choose the incorrect method of securing the equipment. Galvanic corrosion may occur, and the equipment leaking down. So first, what is galvanic corrosion? Galvanic corrosion occurs when two different metals or alloys with different abilities and therefore different electrochemical potentials come into contact with each other under water or in a damp environment. In the event of such contact, the less noble metal acts as an anode, and the more noble metal acts as a cathode, for it is always anode that corrodes. The greater the cathode area in relation to the anode, the faster the anode will corrode. In our example, the screw will corrode quickly, not only because the cathode is larger, but also because the electrochemical potential is greater. Note that the galvanic corrosion may also occur between parts of the same metal if the parts are situated in different surroundings, such as areas with different pH values. For this to happen, the anode and cathode must be in electrical contact with each other. There are three forms of pitting corrosion: air bubble pitting, scab pitting, soft scab pitting. Air bubble pitting appears in the form of small pits containing low soft corrosion products. These are black iron oxide covered with layer of pre-dehydrated ferric oxide. It occurs due to the electrolytic action and can be found on any surface where area bubbles may occur. Pitting. Hard scale of black magnetic iron oxide which cannot be dislodged by wire brush usually occurs in hot part where corrosion products turns into hard scab by heat. It occurs due to the partially or untreatedly impure boiler water containing salts and oxygen. Soft scab pitting. Shallow pitting composed of black magnetic oxide by layer of red dehydrated ferric hydroxide. This type of corrosion usually occurs in superheater tube and heaters and the main steam line. Main reason is deposition of salt due to the priming in superheater and steam mains followed by condensation.
Good day, sir. I am Jason Nico, and I am here to discuss my topic, which is all about high temperature corrosion, microbial corrosion, metal dusting, protection from corrosion, which is all found on Module 2.9. High temperature corrosion is one of the issues for material selection, structure design, service life of an engineering part, which is always exposed to high temperature. The formation of corrosion products such as oxide, which is the common form, carbides, nitrides, and sulfide leads to shorten the service lifetime of an engineering parts. Usually, a temperature or pressure increases directly leads to a higher corrosion rate because electrochemical reactions generally occur faster at higher temperatures. Temperature increases add energy to the reaction, which increases the corrosion rate. Since the 19th century, scientists have been trying to explain the role of microorganisms in corrosion. The damage due to MIC is broken down into a three-step process: creation of biofilm, change of environment at the metal surface, and deterioration of the metal. The common bacteria associated with MIC are sulfate-reducing bacteria, acid-producing bacteria, and iron-reducing bacteria. The most common forms of corrosion influenced by MIC are pitting corrosion, crevice corrosion, and stress corrosion cracking. MIC treatment. A very new aspect of treatment will be based on the possibility of using bacteria against bacteria, or more generally speaking, biological treatment of MIC. Metal dusting is a catastrophic form of corrosion that occurs when susceptible materials are exposed to environments with high carbon activities. In short, it is a corrosion in which the metal is turned to metal powder due to a high concentration of carbon activities. Various treatments are used to slow corrosion damage to metallic objects which are always exposed to weather, salt water, acids, or other hostile environments, such as painting the metallic objects in a vessel or coat it with something that can slow the corrosion damage.
Our topic for today is surface treatments. Surface treatments or preparation involves the removal of old paint, oil, scale, or rust before painting or coating application. There are many surface treatments methods that can be used like dry ice blasting, chemical strippers, lasers, bristle blasting, soda bicarbonate blasting, and lastly, sponge abrasive blasting, with sponges made from abrasive materials. When surface treatments are used to retard corrosion, great care must be taken to ensure complete coverage without gaps, cracks, or pinhole defects. A small defect can act as an Achilles heel, allowing corrosion to penetrate the interior and causing extensive damage even while the outer protective layer remains apparently intact for a period of time. The next topic will be applied coatings. After the surface treatments, the next step will be applying coatings such as plating, painting, and the application of enamel are the most common corrosion treatments. They work by providing a barrier of corrosion-resistant material between the damaging environment and the structural material. Aside from cosmetic and manufacturing issues, there are many trade-offs in mechanical flexibility versus resistance to abrasion and high temperature. The design life is directly related to the metal coating thickness. It is very important to know when it comes to the accuracy of a vessel. Painted coatings are relatively easy to apply and have fast drying times, although the temperature and humidity may cause dry times to vary. Nowadays, there are many different types of coatings that can apply, but among various vehicles or binders, polyurethanes are the most explored in such an attempts.
Preventing corrosion is very important, especially in maritime field. That's why we need to learn how to prevent and how to minimize corrosion. Thank you for watching. God bless and stay safe.